Yeah, I can do that.
It's just disgusting.
Yeah. Wow. He thinks I'm sick. It's so adorable.
Okay, why don't we go ahead and just get ourselves started. I feel like you guys are so far away, but I gotta sort of like be over here to be in the video, but maybe I don't have to be, that's okay. Thank you for kind of coming at this off time. When you do a Friday class and the first Friday is a university holiday, it's just like, oh crap, there goes one whole week of class, right? So I at least wanted to have an opportunity to sort of just do the business end of things and introduce the course, talk a little bit about it, and then kind of get you rolling so that when we have next week, have our official first class with everybody, then we can all sort of hit the ground running. And everyone, those of you who are here, I appreciate you physically being here, and then everyone else who is going to be watching this on a really bad video from what I can tell. But at least they'll get a gist of what went on here. So welcome. You guys are the second graduating class of the neuroscience program. Our first graduating class had 4 students, but I will just let you know, you guys have big shoes to fill. All 4 of them are doing something fantastic and related to neuroscience. One's at Northwestern and a neuroscience program, 2 are in medical school, and 1 is a research scientist in a neuroscience lab in Houston. So everyone, we have 100% success rate in the neuroscience program. So I'm hopeful that this second group will be just as successful. There's officially 18 of you in the capstone, but there's about 20-some students, 23, 24 students who are going to officially graduate this spring. So the second cohort is going to be 6 times bigger than the first. So this class is the capstone, right? This class is actually a liberal studies course, right? It's part of your liberal studies program, but it's offered by the neuroscience program, and it's a neuroscience capstone. So what does that mean? What is a capstone supposed to be? A capstone course for the liberal studies program in general, what we're trying to do in this class is 2 things. One, we're trying to take everything you've learned in your 4 years. I know neuroscience has only existed as officially for 2 of them, but you've been studying neuroscience-like concepts for 4 years. So what we're going to do first is try to make sure you've got a really strong interdisciplinary understanding of neuroscience, right? Many of you, from the little survey monkey thing I did, many of you are more cellular molecular, many of you are more cognitive behavioral. In this graduating class, we do have 3 computational students, although they're graduating next year, so they're seniors, but so they're not in this particular capstone. But you all come from different interests and different subfields of neuroscience. And what I'm also hoping to do in this class is introduce you to aspects of neuroscience that you're like, oh, I didn't realize neuroscience could be applied to that, right? You got maybe a little bit of taste of that when you took Intro to Neuro. We're trying to integrate more interdisciplinary aspects of neuroscience in the other courses as well. Some of you may have taken neuroeconomics last quarter with with Daniel Clark. It's not Dr. yet, I can't call him that yet. So I want you all to get a feel of how interdisciplinary neuroscience can be. It's not just cellular, molecular, and cognitive behavioral. It really reaches beyond that. So that's goal 1. The second goal of a capstone is to take what you've learned in neuroscience and apply it to the rest of your liberal studies program, right? So the rest of your liberal studies program involve things like arts and literature. Okay, how does neuroscience play a role in art and literature? Philosophy, that's an easier one. You may have taken neuroethics. History, sociology, religion. So we're going to get ourselves out of just looking at neuroscience for neuroscience sake, but also incorporate in this class how neuroscience applies to, let's just call it society at large. And I do think that is actually something that is not as far-fetched to conceive of in neuroscience as it may be in some other fields, for example. Okay? So those are sort of the two overarching goals of the capstone. And how we're going to do it is also going to be a little unique, maybe a little different from the other courses that you've taken along the way. Okay? So my goal today is to kind of talk to you, walk through the syllabus, give you a little bit of understanding of the course, and then give you your first assigned readings and talk about like what's going to be quote unquote due for next week. And then that'll be it. I mean, we have an hour, so I just kind of want to give you an introduction to things. Okay. So the other thing is that with capstones, usually you want to focus on a single topic, for example. And when there was only N of 4 students last year, I let them pick the topic. But with 18 of you this time around, I just did it, okay? And I tried to pick a topic that is timely. It is a topic that I think can easily be explored from a cellular, molecular, cognitive, behavioral, computational aspect, and one where you can easily see how that topic can apply to society at large. And so I think I've already emailed this to you all, but the topic this year is officially looking at repeat concussions and how they are linked to neurodegenerative diseases. And I am cheating a bit because this is a topic of my research lab, so I do know a bit about it, but it's probably best if your faculty member knows what they're teaching about. So yeah, so that's one of the other reasons. But there are, like I said, we can explore this one topic in a variety of different ways, and that's what we're going to be trying to do this quarter. Okay. All right. So up here you've got the D2L site, and what I thought I would do is, as I'm kind of walking through the syllabus, I'll kind of help you navigate how I use D2L. First page is always the first page, right? You'll have your announcements. I don't really use the D2L calendar. You'll use your syllabus primarily as a calendar, as well as whatever deadlines I give you in class, okay? In the content areas where you will find your syllabus, okay? So you always have access to an electronic copy of it. I know you all physically here have the physical copy. In this content area, you'll also see, you'll see your assignments. Okay, so I should probably make this, hold on. I should probably make this student view as opposed to my view, because you'll see all the crap that I'm hiding. Okay, that's better. Okay, content. There we go, that's better. So right now you're not going to have all the assignments, but I've got a little bit of the assignments in there for you. And then all of your readings, I will organize the readings based on week. So each week you'll have a folder in your readings folder, and in there will be your readings as well as any PowerPoints that we would be using for that week, okay? And then after that I have a section just for interesting links, and I'll add to that as time moves on. Okay. Oops. I don't typically use the discussion, but if you want to, you are more than welcome to use the discussion place. In a minute, I'll talk to you about your groups and the group work involved, but as you can see, there's going to be 4 groups of you, and you'll be working on things as groups, and so you can use this as a place to discuss if you'd like. But I'm not going to be, I know some classes have you discuss and I grade the discussion. I don't do any of that kind of stuff. Okay? Not on D2L. And then the other aspect of D2L, of course, is we will have grades. I will always be posting your grades in D2L. Right now you may see things that are from last quarter that maybe we will be doing, maybe we won't be doing. Because I taught this for an N of 4 before, it's going to be different from an N of 18. Okay, so not all of the things that are in there are going to be part of your grades. Okay, but we'll talk about what will be graded in a minute. And then of course you'll have an opportunity to interact with each other through emails. You can always contact each other through the class list. And then we will be using, potentially, under more of these things called groups. And this will be a place for you all to share files, share your work, etc. I know many of you use Google Drives and that, but if you don't want to use those and you want to use D2L, I've set it up for you that way as well. Okay? So that's the D2L site. So now let's focus on the syllabus. Oh, I should have introduced myself, but I think you guys figured out who I was, right? By now. So I am Dorothy Kozlowski. I am a faculty member and have been a faculty member in the biology department for a very long time, since 2000. I'm a professor there, and as you all know, my specialty is neuroscience, and a couple of years ago, Dr. Sandy Virtue in psychology and I got together at your request and said, you know what, it's time to go from having concentrations to having a major, and so you all are the reason why we developed the major. And so now, in addition to being a faculty member in biology, I serve as the co-director of the neuroscience program as well. So I'm the one that you guys have been receiving multiple emails from, you know, all the time. I'm originally from Chicago. I grew up near Midway Airport on the south side. I went to Curie High School, Chicago Public School. You may know it from America's Got Talent. They had a group of a cappella singers on there like a couple seasons ago. Anyway, I was not an a cappella singer. My background is behavioral neuroscience. So when I went to grad school, we didn't have neuroscience programs, so I'm aging myself. But my PhD and all my degrees are in psychology. So because of that, my background, even though I took a lot of biology classes, I was pre-med, all that mess, but my focus was always more behavioral in nature. So I call myself a behavioral neuroscientist. And as I mentioned, my lab does focus on traumatic brain injury. We use animal models, and we try to right now, the main questions we're asking are, why are repeat concussions bad? And how can we measure that in an animal model? What are underlying genetic predispositions to that? What are the roles of gender on repeat concussions and things of that nature? Okay. You can find me in McGowan North, just next door, on the first floor, and then my contact information is there. I do not hold official office hours, and the reason for that is because you all have crazy schedules, right? So if I say I'm going to be in my office from such and such and so, and you're working, that doesn't help you. So I prefer to just say by appointment so that we can actually find a time that works well for you, and you can request an appointment either by email or just chatting with me before or after class. We can talk, okay? Readings, like I said, we are going to be focusing on primary journal articles as well as reviews. We also will be reading some media reports. We'll be looking at websites. We are not using a textbook. Why? Because you're not ever going to probably look at a textbook again unless you go to medical school. Even in grad school, very few courses nowadays even use textbooks. Unless you go into education, then you may actually have to pick up a textbook again. But, and the science is right, where you're going to get your information moving forward is going to be through reading articles. And so I want to make sure you all leave here feeling really confident in being able to read journal articles. So that's what the primary readings will be. They will be up on D2L, as I just showed you all, organized by week. I do expect you to read them ahead of time. Okay, it will make class go a lot easier, aside from today, if you read them ahead of time, okay? We already kind of discussed course objectives, learning outcomes, writing. So the liberal studies component of this course requires you all to do a certain amount of writing. And in this class, that will take the form of a final project. You will be writing certain components of a final project throughout the quarter and getting feedback, etc. And in the end, your group will submit, it may be 10 to 30 pages, depending on how crazy you all get. Last year's people had last year's was about 20 something pages long. So you will definitely write more than the 10 pages required, okay? But we also want to make sure you leave here as a good science communicator, both in written form and in verbal form. And so in verbal form, we'll be doing that with class discussions, class presentations, and then in written form through these numbers of different activities that we do, okay? Assignments, so weekly readings. So I'm going to pass out the readings for next week. And later on, once we get everybody in class, you guys can decide, I'll just pass one on each side. You guys can decide if you want me to continue to burn down or take care of trees here, kill trees, or if you want to just have, I know some people just like to read things electronically. I'm a paper person. I need to like scribble and have everything on paper. So I will let you guys decide what you prefer. Today I'll just give it to you all on paper, but you have it electronically up in the reading section as well. Yeah. So if you click on week 1, here are all 3 of those readings. Now when I give you the readings, and I put the readings up here, the order in which they are presented on D2L is the suggested order of reading, okay? They'll make more sense if you read them this, in order, okay? So you will read these papers, okay? And every week you will be turning in a set of discussion questions, okay? And I am passing that out for you now. And this will make up part of your points for the class, okay? I'll wait for everyone to get those around. And I know there's more copies. I made copies for the entire class so that everyone can have their hard copies when we meet next time. Okay. So, how many of you are comfortable with reading journal articles? Like you've done it a number of times, you feel like you're okay with it? Some pretty confident? Okay. I've got a couple of good resources. There actually just came out a paper in like a little article in Science on like tips on reading journal articles. So I'll put links to that up there for you all. But it takes a while, right? I know I just gave you 2 papers, but sometimes it takes a while to get through these. They're dense, they're not easy to read. And so because of that, I do try to give you at least 1 review and then a few others that are more primary in nature. But even so, you're gonna have questions as you read these, okay? And what I want you to do is I want you to actively read. I want you to read these papers and then have a sheet of paper or something to jot down questions on. And this is what you'll be turning in at the beginning of class every week, are these discussion questions. And I will grade them every week, give you feedback, and that will be a component of your grade. And so there's kind of 2 kinds of questions. One are what I call informative, right? And you can read through, what I do recommend is before you start writing your questions, you read through this sheet that I just gave you. That's up on the D2L assignments section as well, okay? And there's 2 types of questions. One are more informative. So these are like, okay, how does an fMRI work, okay? What does CTE stand for, okay? These are questions that I can answer with a fact, or I can send you to a website to read, or things that are easily answered with a yes, a no definition of factoid, okay? I am perfectly fine with you throwing as many of those in there, because what I don't want to do is I don't want to have a more higher order discussion if people aren't understanding the basic information in the paper, okay? So in our discussions, we'll always start with, basic questions about what you all didn't understand about the papers themselves, and then we'll go into more critiquing with higher order discussion questions. And so the higher order questions that I want you to begin including as well in your discussion questions, because they're gonna be the ones that help guide you in our weekly discussions, are ones that you can't just answer with a yes or a no or with factual knowledge. It requires you to think a little bit more. It requires you to synthesize information. It requires you to perhaps refer to another paper or another area of neuroscience that we haven't discussed, okay? And so on this handout that I just gave you, you'll see sort of, what Dr. Alan Webb gives you in terms of recommendations on how to create these higher order questions, okay? And these will be important because, like I said, it's hard to discuss if you haven't read things and if you don't come in with some questions whatsoever, okay? So that will be one component of your assignments that will be graded. The other component is your grant proposal, okay? I already divided you all into 4 groups, And I divided you based on the feedback you all provided me on the SurveyMonkey. And I focused on creating groups in 2 ways. One, and it didn't always work out 100%, but what did work out is basic areas of neuroscience you're interested in. So I grouped you all based on themes in neuroscience that I think you all can explore together, okay? What I also tried to do is, if I could, and it didn't always match out that way, I tried to keep people who are interested in health together versus research versus other things, okay? That was a little harder to do. So I thought it'd be easier to keep you guys grouped based on concepts that you're interested in exploring as opposed to other things. Why? Because as a group, you all are going to work on this final project, this grant proposal. Like I said, we're going to next week go into more gory details about it, but the gist of this is you all are going to collectively decide on a question in neuroscience that you're intrigued about, that you're interested in exploring, okay? First part is you're going to learn more about this question, see what's already out there, see what has been published in this area. Based on what you've read and what's out there and what's published in the area, you're going to come up with a hypothesis or a set of experiments that you're interested in exploring. And you will propose that. Now, this doesn't have to be a typical grant proposal to the National Institute of Health. If you want it to be, that's perfectly fine. Other alternatives are, it can be a proposal to a health organization on how to manage a neurological disease. It can be a biotech company that you're like, hey, we think this cool new compound could be interesting. We think you should develop this cool new compound. It could be to an educational system saying, you know what, you guys are not following the basic neuroscience of learning and memory, okay? Using that, let's think about how you might reform some of your curricula, okay? I'm not trying to pigeonhole you all into a traditional National Institute for Health or National Science Foundation grant. I want you to think out of the box. And that type of final project may be different depending on which group you're in and what your interests are, okay? Mm-hmm.
Should the group topic still be related to the topic of the course?
No. It actually probably doesn't need to be at all. It can be related to it, but it doesn't have to be repeat concussions and neurodegenerative disease. No. And many of you had very different ideas, perception, consciousness, learning, emotions, all over the place. And as a group, so next week, what you're going to be doing is you're going to meet as a group and you guys are going to brainstorm. You're going to talk with each other about like what you all want to learn more about, okay? But it doesn't have to be repeat concussions. It can be something related to it, but it doesn't have to be that. And like I said, the way it's going to go is if you look at the syllabus, the last page, the class topics, you're going to see that we're going to tackle this proposal in chunks, and you're going to work on it. Part of class time you're going to have to work on it, but you all are going to be also meeting outside of class, how best you can, okay? And I know there's so many different ways of you all being able to do that now, okay? I know group work is not easy, and I know group work can turn into one person doing it all. Next week we'll talk about how I'm going to ensure that that doesn't happen. You guys are in your groups are going to be assigning tasks, and part of what this course is also supposed to do is prepare you for careers. And every career out there that you go into is going to require group work, okay? So we're also going to build some of those skill sets. You guys are going to evaluate yourself and how well you did on your group, and you're going to evaluate each other. Not anonymously, but only I will see that, okay? And so I will know if a group is dysfunctional or having trouble or one member is not contributing, and I will intervene, okay? So yeah, I know everyone's like, oh crap, she's gonna make us all work in groups and do group work, but you have to do it. You're gonna have to, all of you are gonna have to do it in your careers. And so this will be, part of this course is also to help you become better at working in groups and giving it more structure as opposed to go work in your group, okay? I'm going to give you much more advice and info on the final project. But this is, as you see, going to be a big component. But it's not going to be one grade all at once with no feedback. You're going to be doing weekly things, and I'm going to be giving you feedback weekly. And your group will be getting a grade, but I will also be very mindful based on the feedback I get on how your group is working about individual grades as well. Okay, so there will be opportunity for people to have, it's not like, you know, your only grade is going to be your group grade. No, there will be individual grades as well. Okay, what else about that? I know we're gonna have more questions when I actually give you more details on the assignment, but any general questions about that? No? Okay. Late assignments, I will be, hi Dr. Kudbach. Late assignments will be accepted, but we will dock off letter grade each day it's late. Your grades, as I mentioned, it's going to be a point system. We're going to use DePaul's point system, and I will take into account group dynamics, and you will have opportunities for individual grades as well, of course, with the discussion questions and other components. Okay? And then the final project, your final, will be a presentation, and the presentation, faculty and students in neuroscience will be invited to your capstone presentation on the last day of class, or the final, okay? So that will be an opportunity for you to verbally present your work to the community, to the neuroscience community at DePaul. Academic integrity, we're going to talk more about plagiarism and all of that, because in science, proper citation is a way to eliminate the idea of plagiarism, but some of the details of that are here. Attendance. So, as you can imagine, we meet once for 3 hours and you work in groups. Attendance is going to be really important. I realize you all have lives, I realize you have interviews and things of that nature. And so please just kind of keep me abreast if you're going to be missing. Keep your group abreast if you're going to be missing. Make sure that you know what you're supposed to be doing and fulfill those roles even if you think you're going to be missing in a class, etc. Okay? Aside from today, well, not really officially today, but I will sort of take attendance today. I'll only take attendance next Friday just to make sure we've got everybody that needs to be in the class. Okay? The syllabus includes information about student assistance, Dean of Students Office, as well as the Center for Students with Disabilities. If you are registered with the Center for Students with Disabilities, I know it, and this class, you will have to help me know how I can assist with regards to this particular class, because it's not like getting an hour and a half instead of an hour for an exam, so it's going to be different. So if there are accommodations that are needed, please talk to me and we can work that out. The Dean of Students Office, I think by now you all are aware that life happens, and if you have something happen to you in your family, in your financials, in your health, in your mental health, that makes it difficult for you to participate properly in the course, let me, but more importantly, let the Dean of Students Office know, because the worst thing you want to do is fail this class, but I can easily give people an incomplete if we work with the Dean of Students so that you can successfully complete this course, and in your case, your degree in neuroscience. So please work with me, contact me ahead of time if issues are happening sooner as opposed to later, but we definitely, if things get out of hand, Dean of Students Office needs to get involved. Okay. The syllabus class schedule, as you can see, it's tentative, and the way we're going to tackle this is we're going to take our topic. Today I'll introduce the topic, and then we're going to break it down by looking at the cellular molecular components, the behavioral cognitive, the computational, and then the more societal, ethical ramifications of things. So these may blend, and we're going to go along with what works best for the group. If you all need more class time for things with your group work, then we'll devote it to that. and less on discussion, etc. But hopefully you'll see that how we're going to sort of divide things up and tackle things up on a weekly basis. Okay? And then, of course, your final is at the mercy of the university. And because this is an odd-timed course, the only time that I could do it is that finals week on June 8th during the time of this class. So if you have conflicts or whatever, let me know ahead of time, because that's really, really close to graduation and the end of things, okay? Assignments, so I kind of, on the side here, wrote more or less when the different components of the final project are gonna be due. Once again, these may get moved around a little bit once we start actually going through the course. But when assignments are due, I want them to be due by 5 p.m. Because then this way, we'll have class in the morning, you guys might have to tweak something or still adjust something and then just have things in. And all your stuff will be submitted electronically for this course. Aside discussion questions you'll turn in weekly, but big final project stuff will be submitted electronically. Okay, that is the syllabus. Sorry, my words are losing my words here. That's the syllabus, that's the general organization of the course. Questions? Okay, so what I want to do next, if I can find it, I know many of you and I recognize many faces, but I kind of want to get a feel for who's physically here today. So why don't you all go around and introduce yourselves to each other. Just let me know and let each other know who you are, what your concentration is in neuroscience, and what you think you want to do with neuroscience after you're done at DePaul. Fair enough?
Sure.
Okay. Who wants to start? I'm not going to. I'm not going to make anyone. Okay.
Hey everyone. I know most of you, but I'm Rachel. I was studying molecular for a while, but then had another class conflict with molecular bios and now general. And what do I want to do with neuroscience? A lot of things. I'm trying to get my master in public health in the fall in like population and family health. So I'm really interested in kind of like neuroepidemiology, then also like, I didn't write this on my thing, but also like domestic violence. I really wanted to go to that one conference, but domestic violence and how that could like, how injuries from domestic violence could like cause concussion and cause CT in the long run.
Hi, I'm Megan. My concentration is in cellular molecular neuroscience. And in the future, I would really like to become a neurologist. For the longest time, I thought I wanted to work with people who had neurodegenerative diseases, especially like the elders of our community. But after I started volunteering with the Children's Hospital at the University of Chicago, I became really interested in working with children. And it got me more thinking about the plasticity of our brains at a young age and how that can help with different kinds of brain injuries to be able to maybe more or less recover from them.
Yeah. Alyssa, I am in general concentration, so I'm going to do the medical school thing, and I'm interested in psychiatry in the long run, mostly with right now I'm thinking people with PTSD because I have like a military background and people with other degenerative disorders. Not as elaborate.
I'm Abby. I'm a cellular molecular concentration, and I also want to go to medical school. And I want to do trauma surgery, but I'm also interested in how trauma affects the brain as well.
Hi, I'm Shabby. I'm cognitive and behavioral concentration. I'm not sure what I want to do with neuroscience. I just really like learning about it. Maybe like education or writing or something like that.
Great.
I am Apollo. I was cellular molecular, also had the same conflict, so instead of general. hoping to go to medical school, and I'm applying to the biggest job. And one thing I've kind of always been interested in is kind of like, I've been interested in chemistry and how like chemicals can affect the brain and stuff.
I'm Garrett. I'm also a general concentration. I'm hopefully starting my master's in the fall next year and then going to medical school after that. And I'm also interested in pursuing like a medical career in neurology and working in like preventative medicine.
I'm Victoria. I'm a behavioral cognitive concentration. Also will be applying medical school this summer. And I don't really know what I want to do with neuroscience specifically, but I know like that will definitely change as I shadow in medical school. But I can see myself doing neurology. I could also maybe see myself doing sports medicine or kind of combining both of those.
I'm Serena. I'm just general, and I really am just interested in research. I thought for a while I wanted to do neuropsychology, but I kind of ruled that out pretty recently, so that's a fair one. But I know I like research, and I definitely have a lot of different topics that I'm interested in. And it's actually funny because I read a book about neuroplasticity, and then I became curious about how the brain repairs itself, and then I found Dr. K's lab, so it kind of worked out really nicely. But I have a lot of topics I'm interested in, so I think I pretty much will probably just stick with research.
Okay. Great. And we'll add the rest of you all who are watching the video next time. But yeah, it's interesting to see because with the neuroscience program, we're so young. I don't know what you all want to do and where you want to go. And so, in the future, I want to make sure that we tailor the program to meet everyone's needs. So it's obviously, I know that health is a big interest of lots of folks in the College of Science and Health. But it's nice to know that there are people who also want to use neuroscience in other ways with regards to writing, education, and things of that nature as well. So, great. Okay. So then the last thing I want to do is give you just a quick, so what I'm going to do each week is give you a preview of what your readings are going to entail. So think of it as like a pre-lecture to your readings, but it's always going to be pretty short, just to wet your whistle and give you at least some terminology so that when you dive into the papers, you're not going in completely cold turkey, okay? Now, if any of you went to my talk in the neuroscience seminar, some of this may be repetitive, so I apologize. But I kind of wanted to give you guys a little bit of an overview of traumatic brain injury, as well as an overview to the topic of why it's become so the focus of media attention in the last number of years. Okay. So basically, traumatic brain injury is defined as any kind of physical blow to the head. So it can be you falling and hitting your head or anything hitting your head, right? And most of the time this is due to motor vehicle accidents, falls in some way, or violence, domestic violence, interpersonal violence, gunshots, all of that sort of stuff. There is a component of traumatic brain injury that is blast trauma. So in the military, folks who are exposed to multiple blasts are receiving concussions from them. What we're finding, and this is not a physical blow to the head, right? It's energy, forces of energy from IEDs and a variety of other types of explosives going through your brain. What we're finding is that even though that does produce a concussion and produces brain injury, the mechanisms of that are quite different from your traditional biomechanical hit to the head. And so our class is going to focus more on the traditional definition, okay? Epidemiologically, our data is really outdated, but it's pretty prevalent. The CDC is working on updating this, but we're talking about 1.7 new cases per year of brain injury with at least 5 million. I'm sure that once again, this is very low, I think, I think that we're going to see more of that. And it's more prominent early in teen years, okay, and also later in life in the elderly, which makes sense if you're talking about violence and fall. Well, violence in early years and falls, and then falls more in later years, and motor vehicle accidents at both ends of the spectrum, right? Earlier on, you have more of them, and then as you age, you can have more of them. Okay? Very expensive. People who live with concussions and traumatic brain injury need lots of care, and it's costly. And many of them, if their symptoms last long, are on disability, they can't work, etc. So it's a very costly. People used to think of traumatic brain injury as an injury, an insult. Happens just then and there, and that's it. You sew them up, you let them go, right? But what the Brain Injury of America and a variety of other organizations, the National Institute of Health, they're starting to realize that brain injury is actually a chronic disease. Okay, just like any other chronic disease out there, because people live with this for the rest of their lives. Okay? There's no treatments. Okay, you can prevent it, you can manage it, and the only treatments out there are rehabilitation. Unfortunately, there's not a chemical out there that we can give someone, not a drug, no magic bullet. Okay? So how does, oops, uh-oh. I didn't realize I should put this on that. That's better. Uh-oh. Okay, here we go. Forgot about my animations. Okay. So when you have a physical blow to your head, right, your brain is like Jell-O, okay? It's the consistency of that. And you're taking that Jell-O and you're shaking it around in a hard cranium, okay? That, if you've taken anatomy and you've looked at the inside of a skull, it's pointy. There's all kinds of bones that go up in there to keep your brain in place. Well, if you're shaking your head and you're moving your brain around along that, it's causing shearing, right? It's causing things to move around in there. And that is what ends up causing a variety of neuropathological problems later on. We categorize brain injury as a concussion versus a contusion. And these definitions are starting to blur a little bit. We used to think of concussions as being more mild, although that's a really bad definition of them. They're only mild because your skull doesn't crack, okay? And you don't have blood and things of that nature. And you don't have pathology. So when you go to the doctor, the ER, they put you an MRI or a CT scan, you can't diagnose that with a concussion. Whereas if you have a contusion, there's a crack in the brain, there's a bleeding, there's a gunshot, something physically penetrating the brain, you can see that on a scan. So that's what separates them. Symptoms are similar, right? There's motor symptoms, cognitive symptoms, emotional symptoms, changes in sensory, your ability to hear things, see things. And what's interesting is that with a contusion, they typically happen immediately, whereas with a concussion, sometimes, as you guys maybe have seen, guys go off the football field and look like they're perfectly fine, but if you've had a concussion, maybe 24 hours later, you've got a horrible headache and you can't walk, okay? So with concussions, a lot of times the symptoms come on a little bit later. Most of the time, concussions resolve if it's just one, okay? It depends on the person, 6 weeks, 3 months, it really can depend. But the effects of a contusion are typically more long-term. There are many instances, though, with concussions that long-lasting symptoms can occur, especially when you have a repeat concussion, which is, of course, the focus of the class, okay? So as you all know, the normal brain functions by signal arrives, goes to the axon, and sends neurotransmitters out to the other cell. And that's a real neuron, okay? You all know, too, that these neurons don't live in isolation, they form circuits. And there are different circuits for different behavioral phenomena, okay, and cognitive phenomena. When I use the word behavior in this class, I mean not just sensory and motor, I also mean cognitive, okay? I lump it all together as a behavior when we think that's a behavior, okay? Now, what happens following a concussion is that when you take those neurons and you stretch them and you bang them against the side of your head, it causes a metabolic crisis. Instead of sodium and potassium flowing properly, you get a lot of potassium rushing out of the cell, okay? And what happens with this then is calcium likes to come in. We all know calcium's good, it releases neurotransmitters, but too much calcium is toxic to the brain, And what this happens then is that this cell is like, oh my God, I gotta get rid of this calcium, I gotta get back into equilibrium, and that's really metabolically taxing on the neuron, okay? It creates an energy crisis. Your brain needs more energy, but at the same time, when you do that to your brain and you shear it and you move it, it affects the flow of blood to your brain. So it actually dampens it and decreases it, which is, like if you think about it, it makes sense, right? If you bang your brain around, you don't want excess blood in there. You want to keep the blood flow low so that you don't bleed out. But what happens then is you've got a metabolically overactive brain that's not getting the blood it needs. Okay? So this causes a big cellular crisis in the brain, okay? And you can't see this, right? There are techniques out there to measure calcium and stuff in the human brain, but you're not going to go into the ER and have these things done. They're more research-based, okay? So you can't see this, okay? Now, over time, or when this energy crisis is happening, your cell's really vulnerable. This process in humans can last a couple of days to a week. So this is one of the potential cellular bases of why repeat concussions are bad. If you go in there and injure a cell again that's still trying to recover from injury number one, eventually it's going to go over the edge and it's going to die. Okay? With a single concussion, typically neurons do not die. Okay? So, and it may, like it says, it may take many days for nerve cells to return. Now, the other thing that happens is, alongside this metabolic issue, is that your axons, your white matter. Imagine a long, thin piece of licorice. Okay. You take that and you pull it and you move it around, okay, and you bring back the licorice. That outer covering is going to look funny, right? That's all the sugar is going to start to ooze out, etc. And if I pull too much, that axon is going to break. Okay. That's also not easily seen on a scan. There's a thing called DTI, which you've probably heard of, that images white matter, that we could start to see white matter damage following injury, but once again, it's more research as opposed to diagnostic at this point, okay? So you've got cells that are metabolically funny, and you've got some axons that are breaking, okay? Axons won't regenerate though. They won't come back. So once you've broken those, you're out of luck, okay? So then what's happening is that these neural connections are breaking, right? You're breaking circuitry, you're messing up circuitry. If this area that's supposed to talk to here is dysfunctional, this is gonna be dysfunctional, and so on and so forth. So you're messing up with your circuitry. So why are multiple concussions bad? Well, you're having concussion after concussion after concussion. You're not letting your brain heal. You're injuring vulnerable neurons. And in your papers, you're going to see that there are going to be longer-term deficits. Okay, these people are having memory and emotion issues when they're 40 as opposed to when they're 70. Okay, and the second paper you're going to read was one of the first, the neurology paper, was one of the first publications to show that individuals with repeat concussions, and these were specifically NFL players, just because that's the data this group had, okay? It's not a problem just of the NFL, okay? But this paper showed that these folks had a greater increased link to neurodegenerative diseases, things like Alzheimer's, ALS, amyotrophic lateral sclerosis, Lou Gehrig's disease. Oh my God, the guy who just passed away, who had it?
Stephen Hawking.
Stephen Hawking. That's ALS. Parkinson's disease. Okay, Muhammad Ali, boxer, multiple hits to the head. He ended up with Parkinson's disease really young. And then the other disease is CTE, and that's what's been in the media more. Okay, CTE is defined as chronic traumatic encephalopathy. Okay. This is a human brain slice stained with something called NISL, just stains cell bodies. Looks nice and blue. These are all just individual cells, neurons and glia. Okay. If you then stain a normal brain with phosphorylated tau, okay, you don't see it. But in people with repeat concussions as early, well, I'm getting ahead of myself, as early as 17 years old, start to have these buildups of phosphorylated tau. Tau is good. It helps your microtubules form. It helps keep neurons their shape. When you phosphorylate it though, they clump. Okay? and it causes dysfunction in the cells. And when we talk about cellular molecular, we'll talk about the energy crisis and the phosphorylation of tau. But that's what it looks like. And interestingly, the tau collects in areas of the brain that directly relate to the behavioral issues that these folks have. For example, this is your hippocampus here, tons of tau compared to other cortical areas, okay? So we think, not we, the general we, I had nothing to do with this study, that the phosphorylation of tau is what may be leading to dysfunction in those brain areas, leading to the long-term consequences seen in some of these folks, okay? So, like I said, it's not just NFL players. This has been seen in a variety of sports. This has been seen in victims of repeat concussions in the military. And there is a movement to try and get brains from survivors of domestic violence and abuse, okay? But multiple areas where you can get a repeat concussion. People have been finding CTE in those brains. And like I said, this group in Boston has actually even found tau in a 17-year-old, which you shouldn't even see at that age. This is just after a few seasons of football. Okay, this is someone who committed suicide. Okay? So it's an issue, right? So why are repeat concussions bad? Well, we don't know. Lots of people are out there trying to figure out why they're bad, but we definitely know that they're linked to neurodegenerative disease. And the hallmark disease of repeat concussion is the CTE, this chronic traumatic encephalopathy. And the leader in this group is Anne McKee, who wrote the review that you have. And she's worked at a brain bank, and they've looked at hundreds of brains now. And we're talking about a 90%, if you have repeat concussions, 90% of the time you will have CTE in some way, shape, or form. So now what we have to do is figure out why and how to overcome it and how to image it, how to know if you have it. So lots of questions out there now for us to explore. Okay? So that's what this class is going to focus on. We're going to look at the cellular molecular components. We're going to talk about how do we, what are the behavioral ramifications of repeat concussions? How do you diagnose things like Alzheimer's and Parkinson's, for those of you who are more clinically oriented. And then we're going to talk about computational neuroscience. We're going to talk about neuroprosthetics, which don't relate directly to this, but they can. We're going to talk about imaging specifically, and because computational neuroscience is going to play a big role in imaging and trying to come up with a way to image CTE in the brain. And then, as you can well imagine, there's a lot of ethics involved here, a lot of philosophical discussions we'll have, effects on society, effects on economics, etc. Okay? So that's your brief intro. And I think you have what you need now to be equipped to read your papers. Read your papers for next week. Come up with some discussion questions. I usually tell you guys to print out two, one to turn in, and then one to have while we're actually discussing. I usually collect them at the beginning, but if you forget, I'll be lenient the first couple of times. Okay? All right, questions? All right, enjoy your week. I'll see you next Friday. Have a nice Easter weekend if you celebrate.
Yes. Question. So since I have to miss next week,
Yes.